Okay, in lesson 15, we talk about right triangles. And a right triangle, as you know, is a triangle that contains one right angle. And there are parts of a right triangle that we need to know. And two of the sides are called legs. And the legs are the sides that are next to the right angle. So notice they are surrounding the right angle. And a hypotenuse is the side that is across from the right angle. So it's also the longest side of a right triangle. In math, we refer to the legs as side lengths A and little b, and we refer to the hypotenuse as side length little c. And we watched a proof of the Pythagorean theorem, which basically says that a squared plus b squared equals c squared. And that means that if we take the side length a of one of the legs and we square it, meaning we multiply it by itself, and if we take the side length b and we square it, multiply it by itself, that will be equal to the hypotenuse, the longest side of the triangle, squared. Okay, so we can put this to use to find missing side lengths. Let us have a triangle. So your tonight's homework deals with finding the hypotenuse. So when we don't know what the side length is, we just leave it. Let's say we have a right triangle with legs the length of 3 and 4. First thing you do is you write the Pythagorean theorem, and then you plug in what you know. So let's call 3a and let's call 4b, and you'll get 3 squared. I put 3 in for a, put 4 in for b, and I don't know c, so I'm going to leave that. Then we figure out what we can, and we know that 3 squared is 9, and we know that 4 squared is 16, because 3 times 3 is 9 and 4 times 4 is 16, and we know that that is equal to c squared. Notice how I'm keeping the right hand side the same the entire time, not touching it till the very end. And 9 plus 16 is 25. And notice I haven't done anything to the right side yet. Now, I know that c squared, or c times c, is equal to 25. We need to use inverse operations to solve for just plain c. So to get just plain c, not c squared, we have to do the inverse of squaring, which is actually square rooting. So if we square root both sides, this gets rid of the square, so the square root goes away and the square goes away, and you just leave left with c. On the other side, we have to take the square root of 25. So it's a number times itself that will give us 25, and that number is 5. So that means that this side length is 5, and that is our answer. Let's try another one that doesn't work out as nicely. So, got a triangle. It is a right triangle. This only works with right triangles. It does not work with other types of triangles. And let's have 6 and 7, and we don't know the hypotenuse. So we write the Pythagorean theorem. Again, we can because it's a right triangle. And the legs, a and b, are 6 and 7. So 6 squared plus 7 squared is equal to c squared. And again, I'm not going to touch the c squared side until the very end. So 6 squared is 36. 7 squared, or 7 times 7, is 49. 36 plus 49 is 85. To undo the squaring and get just what c is, square root both sides, and get rid of my square and my square root. And to do the square root of 85, it's not a nice even number. Nothing times itself is 85 that is a nice whole integer. So what we have to do is we can leave it like that. And I'm just going to do a little aside here, what we can do to make that better. So if we know that there's a perfect square that will divide evenly into 85, we can reduce things a little bit. In this case, there may be, but I can't think of one offhand. Let's see, how many times is 5? If we do 5 into 85, let's see what that is. We get 5 and 17. There is no nice perfect square that divides into 85, so we can just leave it like that. We'll leave it like the square root of 85, and it's a perfect answer. If you want to type it in your calculator and round it, it just makes the answer not as close to the actual answer. And that is how you plug in the values for the legs to find the hypotenuse of a triangle.